Hello viewers, I am Kausalya. Today we are going to discuss about time domain specifications. So this is a particular graph which explains in detail about time domain specification. So this is an output of a second order system with oscillations, right? Here you can see the oscillations. So this oscillation is finally settling down here, right? So in this time domain specification, there are various times. Now we are going to discuss about each and every time in detail. So the first thing is from the graph, it is clear that this is your time, that is x-axis indicates your time and y-axis indicates your C of t, that is output response. So here there are 5 types of time. The first one is known as delay time. So delay time, rise time, peak time, maximum overshoot and settling time. So these are the 5 different types of time. Now I am going to explain the time one by one. So here the first one is delay time. So just look at the graph carefully. So the delay time is nothing but the time taken to reach 50% of the final value for the very first time. So here from this graph you see this is your final value, that is this is your expected output value. So time taken to reach 50% of its final value. So here the maximum value is taken as 1, right? So what is 50% of 1? Then it will be 0.5. So the time taken by the response to reach 50% of the final value. Here this is your final value. So time taken to reach half of its final value is known as delay time. It is denoted by the letter TD. Right. So the maximum value, that is the final value is 1. So time taken to reach half of the final value is half of 1 is nothing but 0.5. So whenever the output response of the system reaches 0.5, that is 50% of its final value here, then that is known as delay time. Right. The next one is rise time. So here this is your rise time. The rise time is nothing but time taken by the response to reach the final value. That is here the final value is 1. So the time taken to reach the final value, that is from 0 to this point. This is known as rise time. Right. Then the next one is peak time. The peak time is nothing but here the expected output is 1. Okay, the maximum value should be 1, but sometimes the output response will go beyond that 1. That is known as peak, that is peak value. That is the expected value is 1, but sometimes the output response goes beyond the final value and that is known as peak value. Peak value and the time taken to reach the peak value is known as peak time. That is this interval from 0 to TP. Right. And the next one is maximum overshoot. So here from the graph, this is your maximum overshoot point. So here the maximum overshoot, it is nothing but it is the difference between your maximum value to the final value divided by the final value. That is C of TP is your peak value or maximum value and this line is your final value. Right. So C of TP minus, here instead of 1, just for our convenience we are making the final value as 1. Okay, the final value may be of any type. So here while writing the derivation for peak overshoot, it is written as it is difference between C of TP minus, instead of this one we are writing it as C of infinity. That is the difference between peak value and the final value to the ratio of this final value. Here C of infinity is nothing but your final value. Right. And the last one is your settling time. Here settling time is the output response after oscillating for a certain time, it finally settled down. So the time taken by the response to settle down is known as your settling time. And here there are some limitations. That is, we cannot expect all the output response to settle by this particular time. So there are some percentage of tolerable errors are allowed. So here the tolerable error is, the limits are either between, that is 2% or 5% error is allowed. That is, the final value would not be exactly 1. It may vary from 1 by a percentage of 2 or 5. Right. Hope you people understand these different types of time domain specifications. Thank you.